Welcome back to the Muse. Today we're looking at something pretty unique. Not your typical skyscraper, but what some are calling the ultimate side scraper, the line.
Yeah, it's definitely a radical concept. We're talking about this enormous linear city. It's planned to be 170 kilometers long, 500 meters tall, but only 200 meters wide.
And the idea is to fit 9 million people in there
Yeah,
on just 34 square kilometers. It's tiny footprint wise.
exactly. It's all part of Saudi Vision 2030, an attempt to tackle, the big problems of modern cities: pollution, traffic, sprawl, while keeping 95% of the surrounding nature untouched. That's the claim anyway.
A huge claim. So today, let's dig into this. We need to look at the architecture, which is just unprecedented.
Right. And how they plan to engineer the climate inside this sort of perfect microclimate idea in the middle of the desert. That's crucial.
Absolutely. And then we have to talk about the well, the elephant in the room,
Yeah.
the massive challenges logistically and financially. I mean, can this thing actually be built for $500 billion? dollars?
That's the core question. So let's start with the design itself. Those renderings, two parallel mirrored buildings stretching as far as the eye can see. It's a completely different take on vertical living.
The scale is just staggering. 500 meters high, 170 kilometers long.
Yeah, that height alone puts it up there with the world's tallest buildings. And the 200-meter width, apparently that's not random. It's supposed to be the sweet spot for letting in enough daylight, but also allowing for natural air movement inside that central canyon space.
Okay, but that mirror facade, it's the defining look, isn't it? The idea is it reflects the desert, makes this gigantic thing kind of disappear into the landscape.
That's the stated goal. Yes, make it part of its environment. But you immediately think,
You think about the birds, right? And just the sheer physical barrier.
exactly. That's a major point critics bring up. The architects Morphosis designed the initial concept. Gensler and others are working on phase one. They talk about blending. But environmental scientists are seriously concerned. A 170-kilometer-long, 500-meter-high mirrored wall, that's a huge potential obstacle for migratory birds and local wildlife.
It's a massive environmental question mark from the get-go.
Okay,
Okay, let's step inside though. They talk about zero gravity living. What's the actual experience supposed to be like?
so it's not literal zero gravity, obviously. It's more about organizing communities vertically in 3 dimensions. Think multiple levels, suspended walkways, open spaces, trying to create more chances for people to interact, maybe.
And connecting that to walkability. They promise everything you need daily is within a 5-minute walk.
That's the central promise for the human experience, because it's linear and stacked. The idea is everyone gets good views. Everyone gets access, whether you're on the ground floor or way up high.
But wait, a 5-minute walk horizontally is one thing. If I'm on, say, floor 80 and the shop I need is on floor 10, 5 blocks down, is that still 5 minutes? Does that include the lift time?
Ah, good point. It's probably more like a 5-minute access window. The design relies heavily on super efficient internal transport, vertical and horizontal, to make that elevation change feel seamless.
Okay, so the vertical distance is meant to feel negligible because the transport's so good. We'll get more into that transport later.
Yeah, the whole city is broken into these modules, maybe 80,000 people each, kind of like stacked neighborhoods. The transport connects them all.
Right now, the climate, a city for 9 million in the desert, promising an ideal climate all year round without traditional air conditioning. How on earth do they plan to do that?
Well, this is where the engineering gets really ambitious. They're banking on the building's design itself, using physics and extensive modeling to create a comfortable microclimate passively. Natural ventilation is the key phrase they use.
So less brute force cooling, more clever design. How does the shape help?
The height and the narrow canyon between the 2 walls are critical. They call it the blade effect. It's designed to work with the sun's angle, high in summer, low in winter.
So it shades the internal space.
Exactly. The structure itself is meant to provide shade precisely when the sun is strongest, keeping those outdoor communal areas cooler without needing massive AC. Plus, the height acts as a buffer against desert winds and dust. The top is open, though, to let the whole structure breathe.
And this passive cooling is vital for their zero carbon goals, right?
Yeah,
Since it's supposed to run entirely on renewables, solar, wind, maybe green hydrogen.
absolutely. If they had to rely on traditional HVAC for a structure this size, the energy demand would be astronomical, even with renewables.
But the construction itself, building something this enormous out of glass, steel, concrete, doesn't that create a huge carbon footprint before day one? Kind of undermines the net zero goal.
That's a massive critique. Yeah. Some analysts have estimated the embodied carbon, just from the materials in construction, could be around 1.8 gigatons, CO2 equivalent. That's huge.
Wow. So they'd have a massive carbon debt to pay off, essentially, even if it runs clean afterwards.
Precisely. It puts immense pressure on the operational phase to be truly net zero from the moment people move in.
Okay, staying on efficiency, water. Starting from scratch must be an advantage there compared to old cities.
Oh, definitely. They don't have leaky, century-old pipes, like, say, London, which apparently loses something like 25% of its water. Here, it's all new, vertically integrated infrastructure.
And the water itself, it's desalinated, right?
Yes, desalinated seawater. But then it has to be remineralized. Standard desal leaves you with water that's not great for drinking long-term, lacks minerals, so they have to add those back in. But building the system efficiently from the start is a big plus.
All right, let's shift to getting around. 9 million people, 170 kilometers, no cars allowed. How do you move everyone efficiently?
Okay, the backbone is something they call the spine. This is a high-speed rail line running the entire length of the city, deep within the structure. That's for the long distances.
High speed. How high? They promise end-to-end in 20 minutes.
Yeah, which means it needs to average about 510 kilometers per hour. That's seriously fast, like up there with the fastest maglev trains in the world. That's the tech needed to make 170-kilometer-long city feel connected.
Okay, so that covers the big jumps, but what about shorter trips? Like, I'm in Module 20, need to get to a meeting in Module 25. I don't take a super fast train for that, surely.
Exactly. That's where the other layers come in. They talk about horizontal transport corridors at different heights within the structure. Think maybe light rail or automated pods, or even horizontal elevators.
Horizontal elevator.
Yeah, systems that move sideways. The point is, you wouldn't necessarily have to go all the way down to the ground or to the spine level just to move a few modules over. You could potentially cross over at height. It completely changes the dynamic of moving through a dense urban space.
Fascinating. And orchestrating all of this, that's the job of the cognitive city AI. We hear that term a lot. What makes this different?
It's the sheer scale and the predictive nature they're aiming for. The AI isn't just reacting. It's supposed to be autonomous, constantly analyzing data streams from transport flow, energy use, supply needs, even, presumably, aggregated resident behavior to optimize everything before there's a problem.
So like knowing there's usually a rush for lifts on the 50th floor at 8 a.m., the AI has lifts waiting there.
Exactly, but scaled up across the entire city for everything, anticipating demand for resources, managing traffic flow on those mid-level tracks, optimizing energy distribution across 170 kilometers proactively. That's the vision.
It sounds incredibly efficient, almost utopian. Zero pollution, instant commutes, perfect climate. But the ambition is just off the charts. Which brings us back to feasibility.
Right? The $500 billion figure for NEOM with the line as its centerpiece. It's tied directly to Saudi Arabia's plan to diversify its economy beyond oil. It's a massive strategic bet.
How do you even build something like this? You can't just start at one end and work your way along for 170 kilometers, can you?
The plan is apparently much more modular. Think giant, pre-engineered sections or blocks manufactured potentially off-site or in dedicated facilities along the route.
Like snapping together massive Lego bricks.
Sort of, yeah. Using standardized components controlled and coordinated through a sophisticated digital twin, a virtual replica of the entire project. The goal is to industrialize the construction process to achieve the necessary speed and scale.
But even so, there's been talk of scaling back, hasn't there? Financial reviews, questions about the initial targets.
There has. The Public Investment Fund, which is bankrolling this, reportedly brought in consultants to look hard at the costs and timelines, especially with global economic uncertainty. There were reports which officials denied, suggesting the 2030 target might be significantly smaller initially. Maybe just a 2.4-kilometer section with 300,000 residents instead of the originally stated 1 million.
Which just highlights how incredibly difficult this is to actually execute on schedule and budget.
Absolutely. It's unprecedented construction.
Okay. Final area, the other major criticisms from an urban planning perspective. We mentioned the carbon footprint and the wildlife barrier. What else?
The big one is the fundamental critique of the linear shape itself. Some complexity scientists and urban planners argue that a line is inherently inefficient for, well, human connection and resource distribution, except along that single axis.
Meaning?
Meaning, if you live at opposite ends of the line, you are maximally far apart. A more traditional, compact, maybe circular city design, they argue, naturally brings more people closer together, making things like community building, shared infrastructure, and local economies potentially more efficient. The line prioritizes long-distance travel efficiency via the spine over that kind of localized density.
So it potentially sacrifices neighborhood cohesion for point-to-point speed?
That's one way to put the criticism. Yeah, it's a trade-off. And we also have to acknowledge the human rights concerns raised early on regarding the displacement of the Huetat tribe from the land needed for NEOM, although this report has been disputed.
Right, that's a serious shadow over the project's beginnings. Yeah, okay, so summing up, we have this vision of a technological utopia, zero carbon, AI optimized, hyper-efficient living.
Yes.
Set against these enormous hurdles, the sheer cost, the construction challenge, the environmental question marks, the fundamental questions about linear urbanism, and the human cost of displacement. It's not just building a city, it's maybe the boldest experiment in urban living ever attempted, trying to leapfrog all the problems of existing cities in one go.
A legacy-free city, as they say. And that AI, the cognitive city aspect, it's designed, as the source material highlights, to use data constantly, to make life smoother, predict your needs, optimize everything for you. Which leads to a thought for you, our listeners. If a city could use AI to genuinely anticipate almost everything, making your commute effortless, ensuring services are always there exactly when you need them, delivering this radical convenience and efficiency, how much of your personal data, your daily patterns, your choices, how much of that privacy would you be willing to trade for that optimized life? Something to think about.